which allows you to create sequences. So for example, I could just say test nums, and I can just say sequence, and here I can say where does it start from. So might be I can say 0 goes all the way to 50, and then I can also say if I would want a jump or how many numbers should be used. So for example, let's do this, and now if I look at test nums, so that shows me the value. However, not to confuse, we could have also done this using assignment operator like this, and then look at your test nums. So it tells me it has created a list of numbers from 0 to 50, which are even numbers. Now you can always do a class of, and let's look at this, and that tells me the objects here are numeric, and say for example I would use type of to see what is this test nums which we just created. There was a typing mistake. Let's check this, and it has the values with double, right? So we have created a sequence here where we are creating a list of numbers which have a space of 2, or you are saying about even numbers. Now you can also use a sort function. So I can do a sorting here, and I can give it in an increasing or a decreasing order. So if for example I have created this sequence, and I could just create a simple variable like this, pass in a vector into this, which could be, say for example, I'll try out test nums, and then look at your v. So those are my numbers, and you can straight away do a sort on your test nums. So I could just do a sort on v, and that basically shows me the number. However, I could also do a sort v, and then I could say here, let's check this v comma, and then you can say decreasing equals true, and let's do this. It just reverse or puts the data in a reverse order, or it sorts based on decreasing value and having the greater value in the beginning and the lowest value at the end. So you can use an inbuilt sort function. Similarly, you can use a reverse. Now reverse need not actually sort the values, it will just reverse the elements in your sequence. For example, let's say v2, and I will again use this one as C, and then just pass your test nums. That's an easier way. Or I could have created a new vector. So I'll say test nums. That's my v2, and you can do a reverse on v2, and that basically shows me the values. But here we see, let's see. So we are looking at, okay, so this was wrong. I should have given a capitals and do it. Yeah, this is fine. And we get the values. However, if I had created something like this, v3, and let's say C, and then let's say 99, and 2, and 3, and 4, and 5, and 78, 100. So that's a vector I'm creating. And now what I can do is I can use the reverse on v3, and you see it has just reversed the elements in the list. Now we could have done this without giving these brackets here, and it shows me the result. So this is good to understand what your sorting does. So sorting is basically going to look at the objects, and it's going to sort them in ascending or descending order. Reverse is just going to reverse the elements in your list. Now similarly, you can also use append, which is basically to combine objects. So let's say v4, and that will basically have append, and let's take v2, and let's take v3, and this is what we would want to append. And now look at your value of v4, which basically has everything added into one. So this is your append. Similarly, you have other functions like finding out the absolute value of a number. You would want to find out the square root. You would want to find the sum of all the elements in a vector. You would want to find out the floor value, exponential value of something, and you basically finding out the mean value. So these are some built-in mathematical functions. So you have built-in simple functions, you have mathematical functions, you have regular expressions in R, which can also be used for pattern matching. Now, what we can simply do is we can create a variable. Let's say text, sorry for caps. Let's say text, and here I will pass in something. R is a programming language for data science. Let's do this. And now I would want to use grep function. So I can say grep, and this one needs what I am searching for. So let's say language. And where am I searching for? So I'm searching it in text. And let's do that. And that tells me where is this found. So when I do a grep, I'm trying to find out if this was found in my element. So here I'm saying text and grep language. Similarly, I can also use one more function, which is finding out index positions. So I can also find out index positions by basically giving the vector, and here I can do a grep, pass in my vector a b c d. You are searching for b and in your vector, and that tells you your b is at the index position 2, d is at the index position 4. So here we are using some regular expressions. Now there are also other ways in which R can be used for data manipulation. So let's learn about factors in R, and how do you work with factors and what are they for. So when you talk about factors, so here let's clean this up and let's see what is this. So when you say factors, here we are talking about categorical variables. So categorical variables can take only limited number of different values. Now don't be confused with this histogram example here. Might be we can just look at packages so that that doesn't get confused. So when we talk about categorical variables, we are talking about variables which can belong to only categories. For example, in R, there is a data structure to work with these kind of variables, and that is called your factor. So with factors, we can be sure that all statistical modeling techniques will handle such data correctly. So for example, you can talk about a person's blood group, and you can say the blood group could be A or B or AB or O. So say we collected information about 8 people and we recorded this information as a vector, and we can call it blood group. So let's do that. So let me try that here. So if I say blood group, and then I would like to create a vector here so that we can look at information about 8 people and their blood group, and this can be in the form of a vector which can then be created or converted into factor by using the factor function. So how do we do that? Let's say I have blood group, and here I will basically give in some values. So I will use C function, and here let's give some values. So for example, let's say B, let's say AB, and let's say O, and let's say A again. Let's again say O, might be one more O. Let's say A, and let's say B. So here we have 8 entries, and let's consider we have recorded the blood group of 8 people, and this is in the form of a vector. So for example, let me create this. Now this is a vector which we have created, and you can always look at the value of this one. So let's say blood group, and that basically, okay, there was a spelling mistake. Let's do blood group, and that basically shows me the values. And here you see all the values that are in double quotes. Now we have basically created a vector. Now to convert this vector into factor, we can use the factor function. And how we can do that is basically we can say, for example, let's go here and let's say blood group underscore factor. And to convert this vector into factor, I will use the factor function and then basically pass my blood group here. And now I have created a factor, and we can look at this factor by just doing an blood group factor. And now if you see, it basically shows us a factor. It does not have any double quotes, and you can also see the factor levels for categorical variables which get printed out here. Now what actually R is doing here is, first R scans through vector to see the different categories in there. Then R sorts levels alphabetically, and then it converts the character vector to a vector of integer values. So these integers correspond to set of character values to use when factor is displayed. Now we can always do a structure to find out more details of this. And here I will pass in blood group factor, and let's look at this one. And this one shows me this factor is with 4 levels. So inspecting the structure will reveal that it has 4 levels. It shows me what are the categorical variables, and it shows me some integers. So here we are dealing with a factor of 4 levels. Now A's are recorded, and A would have, say, recorded as 1. So that would be a first level. You have AB's which are recorded here, and that is basically your second level. B is the third level, and O is the fourth level. So when we are looking at this factor, we may think, why this conversion? So categories could be very long character strings, and each time repeating a string or an observation can take up a lot of memory. So using factors and having these levels can reduce the memory space. Now factors are actually integer vectors, and each integer corresponds to a category or a level. Now to specify a different order of levels, we can specify levels inside the factor function. How do we do that? So let's say I will say blood underscore factor 2, and here I will basically give the same. So I'll say factor, and this factor will have blood group which we had created earlier, but this time also I'm going to specify levels, and then I can basically pass in a vector here. So within these levels I will specify the values. What are the levels? So here I will say O, then I'll say A, then let's say B, and then let's say AB. So this is what we are doing here to specify different order of levels, and we are specifying the levels here. Now if I do this, that would have got created, and let's look at blood factor 2, and that shows me the value here below where you have specifically assigned the levels. Now if you look at the previous one where we had blood group factor where levels were automatically understood by R, so we were looking at the categorical variables, we were seeing what are the levels here, and here what we have done is we have just created again a factor, but then we have specified levels in a different order. And you can obviously do a structure on this to compare. So for example, I'll say structure, and then I will say blood factor 2, and that basically shows me the structure with 4 levels. So this was the initial one where we said A, AB, B, and 0, and then there were some integer values which were responding to these categorical variables. Here we have given a different level, and we have a different set of numbers which we see here. So if we compare structure of blood factor and blood factor 2, we will see encoding is different, right? Now that is done. We can also specify the level names. So what we can do is as we use names function for name of vectors, we can pass vectors to levels here, and there is basically a function what you can use. So let's say I will say levels, and then within this I'll pass blood underscore factor or blood group underscore factor here. So once this is done, let's say blood group. So in this one we created blood group underscore factor, and this one was blood factor 2, so that's okay. I mean, it's just a naming convention. And here let's pass in levels to my blood factor, and then what I can do is I can pass in the values here. So this is when you would want to give specific names, and let's create a vector and let's call it, say, bt underscore a, and might be you would want to give bt underscore ab, and then you will give bt underscore b, and the final one is bt underscore o. So what I'm doing is I'm doing the naming for these particular categorical variables by using levels. Now let's do this, and it says blood factor not found, so we have to look which one did we have. So we have blood group factor, so this is what we should have given. So let's say blood group factor, blood group factor, and now we have given some names here. So let's look at the blood group factor now, blood group underscore factor, and now if you see we have some levels, or we have given the name to the categorical variable. So if you compare this one, so here we were creating a blood group where we had these variables, and these variables were the categorical variables, which was just creating a vector. Then we created a factor out of it, and then we looked at our factor, we looked at the structure of it. And similarly, what we did was we created a different factor. So let me also change the name here, and let me call it blood group factor 2, but here we were specifying levels in a different order. Let's look at this one, so which is blood group factor 2, and then you can look at the structure of this one, blood group factor 2. And here in this example, what we did was the initial blood group factor what we had created, we have just given some names to that, like what we would do in case of vector by using the names function. Here you are using the levels function. So we basically created some levels, and let's group at the blood group factor now, which basically has some different names. So what we are doing here is we are just using naming. Now we can also specify the categorical variable names or levels by specifying label arguments, so inside the factor function. So that is basically to give some names or levels. So let's look at this one. And how do we do that? So we can specify by using factor, which basically creates your factor. And then here I'll say blood group. I'm going to specify labels for my naming. So in previous examples, we saw how we were using the levels, right? And this was by specifying levels for a different ordering. And then we could have also done this by saying levels and given some different names, or we can just do labels. And then within this, I will say labels equals, and then I can say C, and then let's give these values, which we have bt underscore a, bt underscore ab, bt underscore b, and o. So let me just copy this one again, and let's put it here, and then we can basically do a control enter. So I would have created a factor here, and then we should remember one thing here, that it is important to follow and the same order as the order of factor levels, that is A, B, or O. Now these are the levels what we are seeing. So if you look at any one of these in the beginning which we had created, it was showing me what levels it has: A, B, and O, and A, B, and O. So we are following the same order, but we are using the labels within my factor creation. Now, sometimes there might be issues because of wrong ordering. So we can actually use a combination of manually specifying the levels and label arguments when creating a factor. Now, what we can do there is we can say factor, and in this case, let's say blood group, which I'm creating. Then I will basically say levels to give the right ordering. And here in levels, let's say O, let's say A, let's say B, and then let's say AB. So this is for my levels which I'm creating. And then what I can also do is I can go for labels. So levels will take care of my ordering and labels will take care of my naming the categories. So let's say labels, and then we can create a vector and we can give some names. So we can say BT underscore O. What else we have? We have BT underscore A. We can then say BT underscore B. And finally, we can say BT underscore AB. And then let's create this one. So now what we have done is we have created a blood group which has levels, which is following your ordering, which is following the naming as we have passed. So if you look at the levels, it tells you the names what you have created. It also tells you all the categorical variables which were used for my blood group, and basically these will have some labels. So we can anytime look at our blood group which we had created in the beginning, and let's look at the values of those. So when we talk about categorical variables, there are two kinds in categorical variables. So you have nominal or you have ordinal. Now in nominal, you don't have any implied order. For example, blood group O is not necessarily greater than A. That is, O is no or not more worth than A, that we can think of. Now, trying such comparisons with factors will generate a warning. So, say for example, we would want to look into our blood factor, and let's look at what blood group factor contains. Now that's the new blood group factor. Let's say blood group factor, and here I will try to pull out a value here, and let's compare this with blood factor, and let's look at some other value. Now in this case we see not meaningful for factors, so it cannot really compare the categorical variables and see if one variable is greater than other or has more worth. Now there can be many examples where such ordering does exist, and in R we can impose such ordering in factors, thus making it ordered factor. So inside factor we can set the argument ordered is true, and we can do that. Now for example, you would look at the size of a dress. So let's say dress size, and here I will say, for example, let's create a vector, and let's say medium, let's say large, let's say small, let's say again small, and then let's say large, let's say medium, again an entry of large, and then let's say medium. So here I'm creating a vector, and let's see if we missed out any quotes or comma. So it says unexpected symbol, and where is that? So let's look at this one. So we have dress size, and we are looking at C. So I'm saying M, L, S, S, L, and here is a quote missing, and that was the reason. So, and this one also has a quote missing, and now it should resolve. Yeah. So let's look at this one, and now we have created a vector called dress size. Now obviously you can create a factor of this. So I'll say dress size underscore factor, where I would want to look at the ordering of this. So let's create a factor, and in factor we will pass our vector on which we want to convert, or we want to create a factor. We will say ordered equals true. So I am specifying a particular ordering, and then I can also specify levels as we saw earlier. So in levels, we will give the categories. So what categories we have? So we have small, we have medium, and we have large. So these are the three levels which we have. And let's create this as a factor. Now that's done. And what you can do is you can look at the factor, and we can also do a comparison. So let's, for example, look at our factor. What does it contain? It has some levels, and if you closely notice, there are these levels which also have a comparison of which one is worth or more worth than other variable. So you can look at dress size factor, which has some ordering which we have implemented. And now let's do a comparison between dress size and compare it with some other variable and see what is the result. So now it says if it is true or if it is false. Earlier, we were not able to do that because we did not have any ordering. And if we were looking at the variables, we were not really clear if one variable has more worth than others. So these are some simple examples what we have seen. Now we can also look at some more examples. So say, for example, I do a type here. Now that basically is creating a vector. If I would want to compare the element, that is type 3, is it greater than type 4? It shows me false, right? Now here what we are seeing is that if you are looking at a particular value, okay, we can basically see that there is some comparison happening here. If I compare this with 1 and 2, it tells me true or false. And if I look at this, it also does some comparison. So I can always convert this into factor by using the factor function. So I can do this. If I'm checking, if for example, I would want to create a nominal factor, I can do a type dot factor, and it tells me it is true. You can also do a type dot factor 2 and then use the factor function, pass in your type, which is a vector, and here you are saying ordered as true, which we just now saw. And now you look at type dot factor 2, which is creating an ordinal type of variables. Now here we can again create type dot factor 3. So what we are doing here, in this case, we had a vector. We basically said type dot factor. We said factor is of true. And then we looked at the nominal factor. We also did a factor 2. And then we created factor, but we specify ordered as true. So we get ordinal. And now if you look at type dot factor 3, here you are saying ordered, and you're also specifying levels like what we did in the previous example. And now you would look at ordered factor with user given order, which also has the levels which clearly show us a comparison between those. Now we can take a different example. We can say type dot factor 4. We are using the factor function. I'm specifying type, which is a vector. I'm saying ordered is t. I'm using level, which is giving me some levels. And then we also have labels, which are basically going to have the naming convention. So let's look at this one and look at type dot factor 4. So it tells me what are the categorical variables, which are small, medium, large, small, large, medium. These are for my type values, which we created a vector here. These are my type values for which we created a vector. We said ordered is true. The levels is small, medium, large, and we gave some names. So we are looking at the values of this. So this basically helps you to work on your categorical variables, wherein you can then compare the values and you can see what does it show. Now here, what we are doing is we are creating a different vector. We say small, tall, tallest, medium, small, and so on. Let's look at this one, which is basically type, and it has the value. So what we would want to do is we would want to compare height type of first value with the fourth value. So for that, let's create a vector on this type. Ordered is true. Level is we are saying small, medium, tall, and tallest. These are the levels. And now when you look at your type dot factor 5, it basically shows me what are the levels which you have specified. So small is the smallest, then you have medium, which is bigger than small, tall is bigger than medium, tallest is bigger than tall. We have assigned some levels, and based on these levels, now you can compare your values in this factor type dot factor 5. Take the first value, which is small, and compare it with the fourth value, which is medium, and you will know if small is greater than medium, so the result would be false. Now I can also convert this into integer, and I can continue working on this. Now here you have basically a sequence. So let's use the sequence function where I'm starting from 0, ending to 20, and there is a jump of 2. So that basically creates a vector. Let's look at the vector value here. And if you would want to sort the vector, so we are using a inbuilt function wherein let's create this vector with these numbers. I can do a sorting. I can also do a sorting with decreasing is true. You can do a reversing of vectors. So these are some examples of inbuilt functions which we have already discussed. So here you are doing a reverse, you are finding out the structure, you want to append two vectors, you want to check the class of an object, you want to convert a vector into a list using as.list, converting the vector into a matrix. You are having a sample with two random values between 10 and 20. So these are some inbuilt functions which we have already discussed, such as your absolute, such as your vector and getting an absolute value, or getting a sum of it, or a mean of it, a round, or basically rounding it to two decimal places, getting the ceiling value, getting the floor value, truncating it, returning the log, getting the exponential value, and so on. Now, we have also looked at regular expressions earlier. So regular expressions, let's just revisit that. So here you are basically creating a variable called text, and then you can just do a grep. You can say what you would want to search and where you would want to search it. And that would give you the logical value indicating if the pattern was found. You can try to search something else which might not be found. You can also search for independent values like this, and that basically can give you the position of that particular object within the vector. And here is one more example of working with timestamps. So for example, if I would just do a sys.date, it returns the current system date. If I would want to set that as a variable and then call that variable, it shows me our current time. I can also use as date, and then let's look at this one. So as date, and this would be converted into date. And then you can obviously use formatting techniques like getting the month, getting the day, getting the year, So here we are passing in the date, and then we are saying what format we would be interested in, and that basically gives us the data in a particular format. So that's also useful when you have your time series data, or when you would want to convert the data types and so on. Now there are different ways in which you can do formatting. So for example, in this one we were saying month, day, and year. I can also say for getting the full month name or getting the full year name, I can do this caps. So I can look at this one, and that basically shows me my date in a particular format. So these are some inbuilt functions which we are seeing. And before this, we were seeing factors, which is mainly to work with categorical variables. Either they have levels auto assigned and they might not have labels. So you can give labels, you can give levels, you can control the ordering, you can give levels in a different way so that you can have a different ordering. So this is how you use factors and work on categorical variables, maybe that is nominal or ordinal, and easily you can do your statistical computations on such data. Let's learn about data manipulation in R, and here we will learn about dplyr package. And when we talk about this dplyr package, it is much faster and much easier to read than base R. So dplyr package is used to transform and summarize tabular data with rows and columns. You might be working on a data frame, or you might be getting in a inbuilt R data set, which can then be converted into a data frame. So we can get this package dplyr by just calling in library function, and this can be used for grouping by data, summarizing the data, adding new variables, selecting different set of columns, filtering our data sets, sorting it, selecting it, arranging it, or even mutating. That is basically creating new columns using functions on existing variables. So let's see how we work with dplyr. Now here I can basically get the package here. So I can just say install.packages dplyr. Now we already see the package here, which is showing up. So I will just select this one. I can do a control enter, and that will basically set up the package dplyr successfully unpacked. So that is done. Now you can start using this package by just doing a library dplyr, and this was built. It shows me my version of R. So let's also use a inbuilt data set, that is New York flights 13. So we can do install.packages, and that will search and get that relevant data set. I can again call it by using library function. Now once that is done, we can look at some sample data here by just doing view flights, and that shows me the data in a neat and a tabular format, which shows me year, month, day, departure time, scheduled departure time, and so on. Now we can also do a head to look at some initial data, which can help us in understanding the data better. So what is this data about? How many columns we have? What are the data types or object types here? It shows me how many variables we have. So this is fine. Now we can start using dplyr, and in that we can use, say, filter function if we would want to look in for specific value. Now here we have the column as month, so I will do a filter. Now I'm creating a variable f1. I'm using the filter function on flights, which we already have. And then what we can do is we can basically look at the month, where the month value is 07. So let's look at that. And this one, you can do a view on F1, which shows me the data wherein you have filtered out all the data based on month being 7. So this is a simple usage of filter. We can take some other example. We may want to include multiple columns. So we can say F2 filter flights, and here we will say month is equal to 7, day is 3, and then look at the value of F2 if you are interested in seeing this. And that tells you the month is 7 and day is 3. You could also look into a more readable format by using view on F2, and that gives me my selected result. So we are just extracting in some specific value. We can keep extending this. So here we can say flights is what we would want to work on. I'm using the filter function. So I can straight away, instead of creating a variable then doing a view, I can also do a view in this way. I can just pass in my filter within the view, and within this I'm saying filter. I would want to look at the flights, month being 09, day being 2, and origin being LGA, and then that shows me the value here. And obviously you can scroll and look at all the columns, and if you see the origin column, it shows the selected value. So now we have filtered our data based on values in 3 different columns. Now what we can also do is we can use and, or we can use or operators. So I could have done this in a little different way. So I could have said head, which shows me initial result. I will do a flights. So within my head function, I'm passing in this. And what does that contain? So you are saying flights. And in this flights data set, you would want to pick up the month being the column. So we use the dollar symbol here. We give in a value, and I'll say and I'll again say flights, wherein I will select the day being 2 and remember, when you talk about and, it is going to check if all the values are met true. So then you say flights origin LGA and you look at the value. So in this way, I can filter out specifically multiple values by specifying columns. Now we could have done it in this way. We could have created a view, or we could have assigned this to a variable and then done a view on that, where we could have selected month being day and origin. Or you can be more specific in specifying all the columns. It makes the code more readable. So let's look at the values, and here you are looking at head, which shows me based on month, day, and then you can look for further columns for other variables, that is origin being LGA. Now what we can also do is we can do some slicing here to select rows by particular position. So I can say slice, and I would want to look at rows 1 to 5, and I can do this. So you can always assign or look at the view of this. I can just do here. So when I did a slice 1:5, it shows me my entries for 1 to 5. Now similarly, we can do a slice 5 to 10, and now you're looking at 5 to 10 values. So you can always look at the complete data and then you can slice out particular data. Now mutate is usually a function which is used when you would want to apply some variable on a particular data set, and then you would want to add it to your existing data frame, or you would want to add a new column. So this is where you use mutate, which is mainly used to add new variables. So let's see how you work on mutate. So it's pretty simple. So you create a variable over delay. Now I would want to do a mutate so that it adds a new column. So I'm selecting my data, which is flights. I will call the new column as overall delay, and then basically I can look at overall delay being arrival delay minus departure delay. So let's create this and let's look at view of this, which shows me, or which should show me, my new column, which is overall delay, which was not in my original data set. So you can anytime do a head on this one to compare the value. So this one shows me arrival delay, and then there are many other variables. What you can also do is you can do a view, and you could have just look at flights if you would want to compare. So you can look at the flights, and this one would not have any overall delay column. So it basically shows me 19 columns only, what we see here. And if you do a view on overall delay, then that basically shows me 20 columns. So we know that the new column has been added to this overall delay. So if you would want to work with 20 columns, you will use overall delay. If you would want to work with your original data set, you will use flights. Now you can also use a transmute function, which is used to show only the new column. So we can do an overall delay, and at this time we will say transmute, we will say flights, overall delay. The computation remains same, but at this time, if I look at view on overall delay, it only shows me the new column. So sometimes we may want to compute result based on two variables or two columns and just look at the new value, and then we can decide if we would want to add it to our existing structure. Now you can also use summarize, and summarize basically helps us in getting a summary based on certain criteria. So we can always do a summarize, and what we can do is we can look at our data and we can say on what basis we would want to summarize this particular data. So we can do a summarize function. Now summarize on flights, I will say average air time, and I would want to calculate an average. So for that I'm using an inbuilt function called mean. I will do that on airtime column. So let's look at flights once again, and here we can see there is arrival time, not airtime, sorry, arrival time, and we would want to do some average on this particular data. We would want to summarize this. So what I'll do is I will use the summarize function. I will say average airtime, and this one I will look at mean of airtime. So let's see if there is a airtime column. I might be, let's look at this one, arrival delay, and yes, we have an airtime. So we were actually looking at summarizing based on airtime, not the arrival time. So airtime is how much time it takes in air for this particular flight, and we will want to use the summarize function, not the transmute. So summarize flights, average airtime, and this one we will calculate the mean of average airtime, and I will also do a NA removal, which is I'm saying true. So let's do this. And that basically shows me the average airtime is 151. I can also do a total airtime where I'm doing a summation of values, or I can get the standard deviation, or I can basically get multiple values such as mean. I can say total airtime where I'm doing a summation, and then I can look at other values, which is if you would want to put in standard deviation here, you could do that. So let's look at the result of this summarize, and this basically allows me to get some useful information which is summarized based on a particular function such as mean, sum, standard deviation, or all three of them. Now let's look at grouping by. So sometimes we may be interested in summarizing the data by groups, and that's where we use the group by function. So we can always use the group by clause. Now here we are taking a different data set. So we will say, for example, let's look at head of empty cars, and that is basically my data set on empty cars. Now that shows me the model of the car, it shows me mileage, cylinder power, and your horsepower and various other characteristics or variables in this particular data set. So here we can say let's do a grouping by gear. So there is a column called gear, so I will call it by gear. I will look at my data set, and then what I'm using here, which you see with these percentage and greater symbol, is called piping. So that basically feeds your previous data frame into next one. So this is sometimes useful, and you can get this by just saying Control Shift and M, and you can then use this. So we are going to have piping. So I'm saying empty cars. Now this is my original data set where I did a head, or I could have done a view on this one if you would want to see it in a more readable format, and that basically shows me the data. So we are using a different data set, so I want to group it by the gear column. So I'm going to call it by gear, and this one takes my data that is empty cars. I'm using the piping, and then I'm saying group the data based on gear column. That's done. Now let's look at the value of by gear, or you can always do a view. So remember, whenever you're doing a group by, it is giving you a internal object where your data is grouped based on a particular column. So we can look at the values here. You can do a view that shows you your data grouped based on a particular column. Now I can again use the summarize function where I would want to now work on the new one where it was grouped based on gear. So I'm doing a summarize, and here I'm going to say gear 1, which will be having the value of summation on the gear column. And then I'm saying gear 2, which is mean. Well, you could give some meaningful names to this. And let's look at the value of this one, where we are basically now looking at the values, which is sum and mean values based on the gear. Similarly, we can look at different example. So we can say by gear, and I'm again using piping. But earlier we had taken gear, we had grouped the data, and we called it by gear. So we took our original data set empty cars, but now within this particular data, which was grouped by gear, I will take this data set, I will use the piping, and I will summarize it where I am saying within this particular data set, I would want to get the sum, or I would want to get the mean, and then you can look at the values. So what you're doing is you are either looking at your original data set, or you're looking at the data which was already grouped, and then you can look at the values. Now here what we can do is we can group by cylinder. Say might be you are interested in looking at data which is summarized based on the cylinder column. You can do that. And then for this by cylinder, I'm doing a piping where I'm using the summarize function, and summarizing will then be done based on the mean values of the gear column or the horsepower. So let's do this, and then you can basically look at the value. At any point you may want to look at the data set again, so just do a head and you can look at what does the value contain, and by cylinder or by gear, and do a head, and it gives you the value. So you can always do some summarizing or grouping in these ways. Now here we are going to use sample underscore n function and sample underscore fraction for creating samples. So for this, let's take the flights data set again, and we would want to get 15 random values. Now that is done, and it shows me 15 rows with some random values from the data. What you can also do is you can do a portion of data by using sample underscore fraction, and here I'll say flights, I'll say 0.4, which will return 40% of the total data. So this can be useful when you are building your machine learning, where you would want to split your data into training and test. Might be you are interested in some portion of the data, so you can do this, which is very useful function, and then you can look at the value of that. Now what we can also do is we can use a range function. So like we were doing a grouping by, or we were trying to pull out a particular column. So in the same way, we can use a range, which is a convenient way of sorting than your base R sorting. So for a range function, let's do a view based on a range. So we will work on the flights data set which we have, and here what we would want to do is we would want to arrange the flights data set which is based on year and departure time, and we are doing a view out of it. So that basically gives me the data which is arranged based on your year and departure time. Now I can do a head to give me some highlighting of that data. Now the piping operator, what we are using, can be used in these ways also. So here I will say df, I will just assign the data set empty cars to it. Let's look at the df, which has basically your different models. You can obviously look at the head or view of it to look at useful information. We can also go for nesting options, which can be useful. So we are creating a variable called result here. Now that has the arrange function. So what does this arrange function do? So when we would want to use arrange to sort the data, so I would want to sort the data, but what data would I sort? So I will use sample n, which will give me some portion of the data or some sample data. Now what is that sample data? So here we are using nesting. That is, earlier when we did a sample, we just said data and how many random samples we want. But instead of giving that, what we are going to do is we are going to use filter here. Now this filter will work on DF. So filtering will happen based on the mileage, which is greater than 20. I will say size is 5, and I would want to basically arrange this in a descending order. So I'm using the des on this particular mileage column. By default, it is always ascending. So let's get the result out of this, which will basically show me the mileage details in a descending order. So this is my data frame, and now we can look at the result, what we have created. So just do a view or do a head and look at the view. So here you see mileage, where the highest value is on the top, and we were only interested in 5 values in our random sample. So that's why when you did a view, it shows your 5 values and it shows in a descending order based on mileage. So we have not only used an inbuilt function, we have not only arranged the data, that is, we have sorted the data, but we have sorted the data based on a descending order on a particular column. We have said the value should be greater than 20, and we have also said we just need 5 random samples. Now let's look at some other examples. So you can always do a multi-assignment. So I can say filter, wherein I'm going to use DF, which was assigned empty cars. I'm going to say mileage should be greater than 20. Then I say B, which is going to get a sample out of A, and I just want 5 random values. So let's look at that. So we have B, which is going to get a set of 5 values from A. Now I will create a result variable which will arrange B, which is sample data, in a descending order. Now let's look at the result of this, and that basically shows me what we were seeing earlier. So you can do a multi-assignment where you can create a variable, get a sample out of it, and then basically whatever is that result, you can arrange that or sort that in a descending or by default descending order. So same thing, we can do it using pipe operator. So piping. So here I will say result. I'm passing in my DF, that's the data set. I'm using piping, and which basically tells what you need to do on this particular data set. So I'm going to filter out the data based on mileage 20. Then I'm going to push that or forward it to get the random sample, and whatever is this random sample is going to be pushed. So you are arranging this in a descending order. So this is one more way of doing it, and then basically you can look at the result. So these are some simple examples where you can use your dplyr with multiple assignments, or using your nesting to filter out the data. You can also do a arrange, which is to sort the data. You can get some random samples out of it. You can summarize the data. You can also summarize the data based on 1 or 2 or multiple columns. And you can use some inbuilt functions to summarize the data based on some functions which are applied on the variables or on the columns. You can transmute it, where you would be interested in only looking at one column. You can mutate it, where you want to add a new column. You can slice it, and you can give the conditions where you can say and or to filter out the data. So what we can also do is, on this particular data set which we have, say for example DF, where I have my data, let's look at this one. And if I just do a DF at this point, it shows me my data set. And if you would be interested only in particular column, then your dplyr also allows you to, either we can do a filter or we can simply do a select. Now For selecting, we can choose our data. So for example, I'll say df underscore, I'm interested in mileage, I'm interested in horsepower, might be I'm interested in your cylinders in this. And for this one, what I can do is, when I would want to do a select, I can basically say selected df, let's call it some name,